Okay, welcome back everybody. So let's go over another definition. So definition 2, these three operations from the theorem, theorem 1, when we introduced Gauss's method, okay, these are what we call elementary reduction operations or Gaussian operations, okay. Remember, these are the three operations that we can perform on a system of equations, on any one row or multiple rows of a system of equations, and not affect the solution set. So we could swap rows, we can multiply by any row by a scalar, which is, or we call rescaling, and also row combinations where we can combine rows. Now again, when the rows combination, just so you know from the previous video, if you noticed, when we multiply one row and add it to another row, that's basically taking this operation and combining basically in the same thing, right? Because if we multiply by a scalar on both sides, right, that doesn't change anything. Okay. You also might think in your mind is from algebra, right? We know that when we multiply an equation all the way across by some scalar, we know that doesn't change the solution of that equation, right? So this might actually make sense to you from previous classes you've had, okay? And of course, row combination is just kind of like adding a multiple of another row, which is, again, we take this and we're just adding to other equations. Now again, the key is these are combining equations, linear equations in the system. Okay, so those are your elementary reduction operations, and that's what we're going to be using now. Now in the textbook, different textbooks use different symbols. Some textbooks use Greek letters. Row 1 is going to be the Greek letter row with the subscript 1. Some people, like me, I'll just use capital R1 for row 1. So again, the way we're going to do these row operations, you'll see. Okay. Whether you look at the textbook and they use something different, it's pretty much the same idea. Okay, you'll get the hang of it. But anyway, I'm done talking. Okay, we'll do some examples now.